3, 2, 1, 0. Welcome back to Mr Mickleburgh's Maths World. Here we are doing our last problem for our practice test. Now, what we've done before is rotate this shape about the x-axis. Our question here is, well, if we rotate it around the y-axis, do we end up with the same volume? And justify our answer. So we've just got to do it. Now, the big thing here, two big ideas. Firstly, we are going to make x the subject of our equations, okay, and integrate in respect of y. And then, as usual, you need to worry about your limits. Generally speaking, when you do that, when you rotate around the y-axis, your limits change. But in this case, they don't, by coincidence, because when x is 1, y is still 1, and when x is 0, y is 0. So that hasn't changed. Okay, so really what we're doing is this to refresh your memories. Volume equals pi. In this case, it's actually x squared, and our limits b and a, and we're going to integrate in respect of y. Okay, so what is x when we make equal to, when we make it the subject of our equation? Okay, x squared. We take the square root of both sides to reveal that x equals the square root of y. Generally speaking, when you take the square root of both sides, you need to consider the positive and negative case. In this case, not so, because we know we're in the positive region only. Now this one, well, if we reverse it, x is the subject of our equation, and that is no problem at all. So, okay, what do we do now? Well, because it's an area between two curves that we're rotating, we're going to take from this curve, that curve, we're going to square it, integrate it, times by pi. They're the broad steps involved. So, let's have a look at and see what we get. We are going to say the volume is equal to pi. By coincidence, our limits don't change. And what have we got? We've got that one. Square root of y minus y, all squared dy. Okay? Now, firstly, we've got to square it. So, volume equals, we can't use the chain rule here because, the chain rule for integration, because the highest, we've got a square root of y there, unfortunately. So, anyway, first term squared is simply y. Now, twice the product of the inside terms is 2 times square root of y times y. Just leave it like that for the moment. And then the last term squared is fairly straightforward, so we're just expanding perfect square. Then we integrate in respect of y. Now let's have a look at this. It's not in what I'd call calculus friendly form. 2 square root of y, well that's y to the power of a half, isn't it? Times y. That's going to give me 2 times y to the power of 3 on 2. So volume, 1, 0, y minus 2, y to the power of 3 on 2, plus y squared dy. And once again, I left out the pi, but it's back in now. Okay, so going over here, hopefully I've got enough room. I now have to integrate. So this should be reasonably straightforward. So the volume, here's the integration line, is equal to, well, that's just y squared on 2. And what have we got here? Now, minus 2 lots of 3 on 2. If you add 1, it's just going to come to 5 on 2. So 2y, the 5 on 2, over our new index. We'll have to tidy that up in a minute. And what have we got here? Plus y cubed on 3. Plus y cubed on 3 is what that says, if you can't read it too well. Y cubed on 3. Our limits are 1 and 0. Okay, let's tidy this up a touch and we're nearly done. Therefore, volume equals pi. And y squared on 2, there's nothing wrong with that, as it is. Okay, let's have a look. When we divide something by a fraction, we tip it over and multiply. So it's going to come to 4y to the power of 5 on 2 over 5. Why 4? Because it's 2 by 2. Okay, minus 4y to the 5 on 2 on 2, on 5, sorry, plus y cubed on 3. Our limits should be there. Yep, I'll just squeak in. Okay, fortunately 1 and 0 are nice to substitute in, especially 0, because it generally comes to 0. And this is what we get. A half. What have we got here? 1 to the power of anything is 1, so it's 4 times 1 is 4 divided by 5, so 4 fifths. And 1/3 plus 1/3. Don't know what that square bracket's doing there, that should be a round bracket. Okay, so it looks like our common denominator would be something like 30, wouldn't it? 2, 5 and 3. So the volume equals pi, square bracket, round bracket, over 30. We times that by 15 to get to there, so that's 15. We times that by 6, so we times that by 6. We times that by 10, so we multiply that by 10, plus 10. Whoops, plus 10. Just remember that says plus 10. Okay, so we've got 15 plus 10 is 25. Take 24 is 1. So the volume equals pi times 1/30. In other words, the volume equals pi on 30 units cubed. And that's how we rotate it around the y-axis.